Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. So this video is about my project, the serverless unicorn ride-sharing application. My name is Raja, and this presentation will take you through the project objective, architecture, and the workflow of summary this project. So let's dive right in. So the goal of this project was to build a scalable and secure ride-sharing platform using AWS services. So my goal was focused on leveraging serverless architecture to ensure efficiency and cost effectiveness. There are some key features here, including user authentication through AWS Cognito, dynamic unicorn assignment for rides, and real-time ride logging in the DynamoDB. Okay, next. Here is an overview of the system architecture that I use. To the source control system is the GitHub, the coding, and I use the AWS Amplify to build and host the website from the GitHub. And at the core here, I use the Amazon Cognito to handle user authentication, ensuring a secure sign-in process. Next, I use the Amazon API Gateway act as the bridge between the front end and the back end. So this is involving AWS Lambda functions to process write requests, and that I have here is the Amazon DynamoDB serve as a database for storing write details securely. So these together are the components to create a seamless and serverless experience for our user. So next, the backbone of this project is a suite of AWS services. So AWS Lambda process all the back-end logic triggered by user actions. So I use the Amazon API Gateway to ensure smooth communication between the front end and the back end. And the DynamoDB provides a reliable database for storing write details, and AWS Cognito simplify user authentications. Next, the workflow. Now let's look at the user workflow. First, users sign in through a Cognito. They select their pickup location on the front end, which triggered an API call via API Gateway. Then, the request involves a Lambda function that assigns a random unicorn and logs the ride in DynamoDB. And finally, the user receives a confirmation with their assigned unicorn detail. So next, I will show you the demonstrations of the project. So I will continue for the demonstration part. So first thing first, I will talk about for the GitHub. So the GitHub here is I use from a template from a tiny technical tutorial. So it's just a easygoing site to use the GitHub, because it actually is a very cost effective for small project like this, because it has a free repo and limited private repo. So, and it also have a very large collaboration between developer community, so it have more support. Next, so this GitHub actually will connect it with our AWS amplifier. So let's go to the console. Yeah, we go to the amplifier. So this AWS amplify where you can choose a source code provider to deploy your front-end applications, because it provides option actually to deploy your app from a Git provider such as GitHub, Bitbucket, CodeCommit, and GitLab. So for this case, I choose GitHub uh, as a source code provider. So after granting Amplify the necessary permission to access your repo, you can choose the branch you want to deploy. So that Amplify will then handle the build and deployment process for you, making it a straightforward way to host your front end on AWS. So updating code in a GitHub and integrating it with AWS Amplify is a straightforward, because Amplify support continuous deployment by syncing with your GitHub repo. So this is the history that I make the changes. You can see the started here. So the auto build is the first time I deployment the front end application. So AWS Amplify detects the update. So it always continuously monitors the branch you connected during the initial setup. When you push a change to this branch, Amplify automatically detect the updates. So once the Amplify detects the changes, it triggers a new build process. Amplify fetch the latest code from the GitHub, runs the build commands, and deploy the update version of your application to the Amplify hosting environment. So you can monitor the build and deployment status in the AWS Amplify console. So here, the Amplify will deploy the update version of your application to the Amplify hosting environment. So you can see what we do at the GitHub. So example, update index, update config.js here, and the time. So after the build process is complete, the update version of your applications is live and accessible through the Amplify host URL. So Amplify ensures that every deployment is atomic, so user will only see the fully deployed and working version of the app. So this workflow makes it easy to integrate GitHub with AWS Amplify, ensuring a seamless deployment pipeline where any update pushed to your repo are automatically reflected in your live application. Next, we will go to the Amazon Cognito. So Amazon Cognito is a service that simplify a user authentication, authorization, and user management for web and mobile application. So to integrate Amazon Cognito with your application, you need to copy the user pool ID and application ID from the AWS Cognito console and add them to your application code. So we have the user pool ID here, and with the application ID here, and two distinct is very important that we need to paste at our code in the GitHub. JS, we have the config.js. So this we need to use this. So then if anything changes, we need to go back to the console, and if we change the deploy the new one, so this is making the cognitor ready to handle user authentication. If you see here, if you see here, there's already 3 users that are submit. So we can see it from the user management. Here there are 3 username here. So this is from the sign up page. So when a user sign up through your application, Amazon Cognito can send a verification email to ensure the provided email address is valid. The user must verify their email before their account becomes fully active. So once a user has to sign up and verify their email, they can log into your application. The login process involve authenticating the user using their credentials like username and the password, and obtaining temporary tokens to access resources. Okay, next we will see the implementing ride sharing functionality with AWS Lambda and DynamoDB. Go to the console. We have firstly we go to the DynamoDB. And the table. We create the DynamoDB to store ride sharing data. Okay, next we create the Lambda function. So we go to the console, go to the Lambda, here the function that I have been created. So there I use the code sources from a GitHub, and here we got. So actually we need to attach a policy to my Lambda execution rule that allow reading and writing to DynamoDB table, but unfortunately to create rule or update rule that is not given permission for this lab. So I use the already created in the lab, and luckily it gives the same function that can allow reading and writing to the DynamoDB tables. So the API gateway is created using the RESTful endpoint for each Lambda function. Okay, next we will go to the code explanation here. From the fleet here, that this function pick a random unicorn from the tree and name Angel, Kate, and Rosinette. Making each ride is a unique. Now we have the DynamoDB integration code which store ride details like ride ID, unicorn, 88 30-second of the rider with the username here. Okay, now so let's test out our application. So let's go back to the console, go to the our. Okay, before that I will delete the username that I have signed up using my emails. So we go to the Cognito, and we go to the user, and I will delete the Nafisa Raja here, and delete. Okay, so let's make the sign up with the email Nafisa Raja. So we go to the console back and go to the amplify, and go to the here, and we need to go to the application itself. So I make a little update here that easily that can be signed in. Hit the here button. So for the sign up, we click this key up and use the email here and create a new password. And click right, and this means that the computer will send a code to your email, so make sure you sign up with a valid email. So let's go to the email. Okay, so this is the new one. So copy this and paste this code and verify. So this means that your email has been verified and you can log into the page. Next, the password. Can sign in. Okay, see, it will be a little time, so you can zoom in and choose your location, any location here, and you can click the request your record. See, it will automatically choose from the three right. It will automatically choose your unicorn. So you can see that it has been arrived, and your unicorn is white name kill. Okay, so that is how this application works. So to see this detail, we go back to our console. Okay, so we go to the Cognito. See, your tree here, users, that is a new one. Next, if we want to see the request right, we go to the DynamoDB. We go to the table, click right, and explore table item. Can see here, this is the request item that from the user. So the latest one is here. Can see the times is here, and the color names is kill, male, is a white. So it perfectly same. So, conclusion, I have successfully built a serverless ride-sharing application that leverages AWS service. So, this project demonstrates the potential of serverless computing to simplify development while delivering a secure, scalable, and fun application. It was an exciting learning journey actually, and I'm confident this platform can serve as a foundation for more advanced features in the future. So, of course, no project is without its challenge. So, I think when I create this project, the most challenging is the understanding the intricacies of serverless architecture. So, I follow AWS documentation, um, YouTube, the Google, and the tutorials to gain a deeper understanding. So I think that's all from me. Thank you. I hope you enjoy watching my video.